दोस्तों आज हम स्टर्न गेलाक एक्सपेरिमेंट परफॉर्म करने जा रहे हैं. आई वुड लाइक टू डिस्कस दिस एक्सपेरिमेंट एंड what was the outcome of this experiment. What was the significance, इससे हमें क्या पता चला. I will not go into the deep history that it was invented by Stern and then they performed, Gerlach and Stern performed all together, both of them. So my main motive is to explain it. What was the outcome of this experiment and how I will try to connect it with the Dirac's notations, cat and bra. So after explaining it, I will slowly move towards these direct cat and bra operators or states, whatever you call them. And I have tried my best. I have experimentally, I have gone through this research related to the Stern and Gerlach experiment. I believe it will be a little helpful. So there are some basic concepts, basic requirements to perform this experiment. We need varying magnetic field. For this experiment, we need the special variation of the magnetic field. We need silver to perform this experiment. Why silver atoms and why not the ions in this experiment to perform this experiment, and what is the significance? So I'll tell you the motive of this experiment, and then I will not go deep into the analysis. My main motive is to explain the outcome of this experiment, and then I will move to the Dirac cat and bra notations, how this experiment can be explained and how it is related to the polarization of the light. And basically, this experiment is the quantum mechanical evolution, I would say that, right? And here, so what are the fundamental requirements, how this experiment is being performed? In this experiment, what we use silver atoms. They are heated in an oven. They are heated in such a way that we get the vapors of silver, or we get the silver atoms. They are aligned in different directions. So what we do, we have a hole in this oven through which the silver vapors they come out of this oven. By using a beam collimator, we make a fine beam of these silver atoms, right? And this fine beam is allowed to pass through a magnetic field which is not uniform, or we call that magnetic field as inhomogeneous magnetic field. I will write it here. So this magnetic field is applied along the z-axis. So, and that means inhomogeneous means it is changing along the z-axis, but that change is constant. So that change is constant means that curly bz upon curly z is constant, and the other factors, they are zero. So this is a significant, this is the use of the inhomogeneous, and why we use this field that can be explained mathematically as well. So what happens, this fine beam of silver atoms that pass through the magnetic field and it experiences a force deflection. Why it experiences a force? Because because of the magnetic moment of the silver atoms. So magnetic moment of silver atoms, the silver atom has 47 protons, 47 electrons. So these 47 protons and 47 electrons, they are such a way that these 46 electrons, they form a cloud, a symmetrical cloud, such that their net magnetic moment is 0. And the only electron, that is 5s electron, that is responsible for the spin magnetic moment of the electron. Now this system is altogether a whole system. So we say that the net magnetic moment of the silver atom is due to this 47th electron. So that means the magnetic moment of the silver atom is proportional to the spin of the silver atom. That's the reason we use the silver atom, because these 46 electrons, they form a symmetrical cloud. So the magnetic moment of the pair, net magnetic moment of the pair is 0. The resultant magnetic moment is due to the spin of the 47th electron that's present in 5s shell. That gives the magnetic moment to the entire atom. So due to this spin magnetic moment, due to this spin quantum number, you can say that due to this spin magnetic moment, when these atoms pass through this magnetic field, which is specially varying, they experience a force, right? That force is given by Fz equals to mu curly Bz by curly Z, right? So these atoms, when they pass through this inhomogeneous magnetic field, they experience a force that is given by this, or that is, you can say, that is proportional to interaction energy. Interaction energy is given by minus curly U by curly Z. F is minus curly U by curly R. U is the interaction energy here. So this is how the force acting on the electron is calculated, right? So now this curly B, now since Bz is not constant here, it is changing along Z axis, so this factor is not 0. So the electrons, because the field is changing along Z axis only, and the electrons experience force only along Z axis, and rest of the components are 0. That's the purpose of using the inhomogeneous magnetic field, because if the field is constant, it will not be changing, so this factor will be 0 and there will be no net force acting on it. So mathematically we can prove, we can write this way as well. So what happened? These atoms are passing through this magnetic field and they are spinning. Now we will be coming to two different points. The classical concept, right? So the electron spin, the electrons here, they are randomly oriented. They do not have any particular direction, right? Their spin can be anywhere in the direction. The spin magnetic moment can be in anywhere direction. So there is a random direction. So when atoms, they pass through this, they are deflected, and we have a screen here which is cooled, extremely cooled, so that when the atoms, these hot atoms, when they hit this screen, they just immediately cool down, and they do not like flow downwards. So they leave a spot here like this. Depending upon the spin, they leave the spots on the screen. And classically, because all the atoms they are oriented in, the spin of the every electron is like random, they are oriented in every direction. So the screen should be filled like, so that we will be getting the spectrum continuous from minus mu to plus mu. This will be the spectrum, this like classically, because so the range will be this. So that's quite obvious, because there is no finite direction, the electrons are randomly oriented and they will be deflected in particular direction depending upon the angle to which they are inclined. So this is the classical concept. However, experimentally, it has been seen the spectrum of the pattern obtained during this experiment is this much. So that, like, you can see this is a gap here. Now what it means? It means that although the electrons might be like, we are not sure about the orientation, that means the atoms, silver atoms, they are collected upon on the two sides, on the two spots, and there is a gap. That means there is a discreteness in the magnetic moment of the electron. So the discreteness in the magnetic moment of the electron, that means, because magnetic moment is directly proportional to spin of the electron, so that means there is a discreteness in the spin states of the electron. Because if they are random, they are like, there is no particular direction, there would have been a continuous spots of the silver atoms on the screen. Now, since we get the two outcomes only, we have the two discrete spectrum, I use the word spectrum. There are two discrete regions here on the screen. So that means this is not a continuous, right? So the electron spin has two discrete values, and that leads to the quantization of the electronic spin. So the word is quantization. So like when I studied the quantum mechanics, the first thing, the first word which you should remember is, or you should understand, is quantization. Quantization is discreteness simply. So when we talk about the quantization, it is discrete, that there is nothing continuous, as is in the case of classical mechanics, right? So this is the postulate of the Stern-Gerlach experiment. This is the main motive, this is the main purpose, that electron spin is quantized, and the electron has two different spins. One is spin up and spin down. Depending upon the value of mu, the electrons are deflected in the different directions, right? So this mu, it has only two values. So depending upon that value of mu, the electrons are deflected, right? So this is the main purpose of the Stern-Gerlach experiment. Now, moving further, we will discuss, now we are not sure about what happens when the electrons are allowed to pass through the different setups of Stern-Gerlach experiment. That will lead to something very interesting. So I have gone through the videos on the YouTube related to Stern-Gerlach experiment, and many teachers, professors, they have explained this experiment very well, and so you can get the mathematical details of this experiment on the YouTube or any channel, but my main motive is to explain the experimental consequences of the Stern-Gerlach experiment, what is the significance of this experiment. So now when I talk about passing using this experiment as a single experiment, now I will discuss the sequential analysis of this experiment. And ultimately, we will be heading towards Dirac's cat and bra notations. So now, the electrons with, now we have set up, I'll explain, this is the oven in which the silver atoms are placed, and it is being allowed to pass through a Stern-Gerlach experimental setup. I will use the word Z cap. Z cap means the magnetic field is applied along the z-axis. That's the purpose of using this. So that means magnetic field is applied along the z-axis. So you get the output as the two beams, right? And it hits the screen. So the one hitting the top of the screen, that I referred with the spin positive, the electron beam, the electron having the spin positive, and the one with the one those hitting the beam on the lower side, I refer them that their spin is negative, so I call them SZ negative. So the two beams of the silver atom, they possess the electrons, one with the spin up and one with the spin down. So this is a like experimentally proven thing. So this is the setup how it runs, right? So that we have answered. Now what I do, I use the oven and I pass it through the same apparatus, again the Z cap, and I pass this one and I block this SZ negative spin. So the electrons with this spin down, you can say, or with spin up, you can say here, spin down they are blocked, and with spin up they are allowed to pass, right? So when these spin up electrons, they are allowed to pass through another SX cap apparatus. Now what it means? It means that the magnetic field is towards the positive X direction. Now what happens here? Here you got the two components, one with SX plus and one with SX negative. That's quite understood, that when it is passed through the the magnetic field is applied through SZ, the electron beam with the spin up is allowed to pass through a apparatus having the field along x-axis. We get the two beams, one with spin positive x and one with spin x positive negative. So like you can say what we interpret from here, usually we can say that this beam is comprised of SZ plus, SX plus, and XX plus and SX negative. So when it is allowed to pass through this apparatus, this portion is blocked and this one is allowed to pass. So this is what we can interpret from here, right? Now this SX positive beam that is allowed to pass through again, and this one I block. This is blocked, and this again I pass through SZ positive, right? Now what could be the outcome? It's very strange to see that output here again is SZ positive, SZ negative. This is the concern. The concern here is SZ negative, how does it appear? Although we have blocked the SZ negative component here. This is quite similar to when I say I use a polarizer. For example, I use a polarized light and I pass it through X filter. X filter is that polarizer which will allow the component of the polarization light to pass through it, which is parallel to x-axis, right? I get the output along x-axis, right? When I pass this light through y-axis or y filter, sorry, I get no output. That's quite understood, right? Now what happens in another case? If I pass this, I get the output, right? And I pass it through X prime filter. Now what is X prime filter? I take an example. X prime filter is a filter whose axis or whose optic axis is at 45 degree to the x-axis. I get the output, right? And now when I pass this through a Y filter, that of course we are using the 100% filters, both of them, X filter, Y filter, X prime filter. When I pass this beam, this light through Y filter, what happens? What's the output? Remember here, I am using the X filter and I am passing it through the Y filter, I get the no output. Again here, I use the X filter and the output of this is being passed through the Y filter. What I will get? You see, the difference here only is the introduction of the X prime filter here. Okay, so here what we get? Here we get the output along the y-axis. So that means the introduction of X prime filter, it has changed the status. You can say the status, I will use the word status. It has changed the whole scenario, right? The whole scenario is being changed. So that means the output which is coming out from X filter and is fed to Y filter, that has nothing to take from the output which is coming from the X filter. So this output, so whatever is being done by X filter is of no concern of the Y filter. Similar is the case here. Whatever is the output of this SG X is of no concern to this. So it can be said that the output coming from any of the experimental setup is the combination of the different inputs. For example, if I get the output here, this output, I would say this is the linear combination, or this is the combination of the two different states. That concept I will explain. So that concept was beautifully explained by Dirac, P-A-M, Pauli Dirac, in his Dirac-Cat and Bra notations. So this is how I did it. You see, I didn't use the concept of quantum mechanics here. I only discussed the polarization states. I didn't talk about the photons. So I'm concerned about the polarization, which is being explained classically as well. So I have not talked about the quantum polarization of the photons. That's how classically we are moving towards the quantum concepts of the spin states. So this is the main significance of Stern-Gerlach experiment, that the spin of the electrons is quantized, and the two states, and any physical state of a system, of quantum system, can be explained or can be demonstrated by can be more simplified by using the base states, right? So those base states, they are known as cats and bras. Okay, so but it's still little more to go with the polarization of the states and the polarization of the electric field, or the light. So this is how the Stern-Gerlach experiment can explain the quantization of the states. Thank you.